पड़ोसी देखा जाओ नहीं रे प्रेजेंटेशन टा ओपन हैं you open your smartphone that you are smart calculation if it is not possible then you can open your expecting that is it on accessing a smartphone doesn't mean that you are eligible to open your or surfing your social services. Social services are ठीक है because you are in class so you are paid for that even it is a public funded institute you paid little bit of amount for each class right okay so today we are going to cover up the topic of two important things. One is the instrumentation standards. Okay. So one is the instrumentation standard we are going to discuss. Number two, right. That is one thing. Before this, we are going to discuss the requirement of V2D and V2A in the exam. So this is something you have been already studying. Done? Now, when say you are going to deal or industry application where you are continuously observing certain physical parameters, and out of those n number of physical parameters, there are n number of parameters that you are constantly monitoring, and rest n minus m parameters you have supposed to not only monitor it, but you may also require to control it. Clear? Then out of this n minus m, there are certain parameters. Those can be digitally regulated, that can be digitally instructed to do a needful task. For example, opening and closing of the valve. So if I need to just take care of opening and closing and I am not bothering about the intermediate states, then I can simply handle this action using one binary setting. Okay? With the proper identification of the location and encryption and decryption tools. Done? Number two, rest of the signals you might need to regulate on a continuous way. So remember, you are doing two-fold tasks at the same time. One is the exchange of data between the control center, and now when I say control center, primarily I am interested for controller, because controller is acting as a brain of that particular automation. There is a HMI, those big screens what you see, through which we got a human intervention with the machine, or you can say that you can interact with the machine at one step ahead. Okay? So you can say human machine interaction is one thing, human machine interface is the another thing. So the basic thing is human machine interface. If you want to add some real time visual interaction, then that is called human machine interaction also. So it's something different matter. Yeah? So you require combinative techniques and all other things, keep it up. Right. So keep it simple. Here my HMI is human machine interface. One side human personnel is there, maybe engineer is there, maybe operator is there, another side machine is there. There is an interface through which you are establishing a real time communication with all those machines, those are acting upon, okay, following to some instructions sent by the controller. So primarily you are interacting with the controller, and through controller you are interacting with those smart devices, those smart sensors, smart actuators, and as per your instruction those smart sensor and actuators acts upon you depending on the type of instruction it is kept on getting from the controller. This is clear? Okay, so three main things. One, the human personnel. Another is the controller. Third thing are the field devices, I will say. When I say field devices, that means it comprises of all the sensors, actuators, any kind of device which is controlled and monitored by some kind of automation platform or using some automation platform. Okay. So out of which there are certain signals, that means there are certain data which you constantly need to monitor. I would say constant monitoring, or I would say that constantly controlled and monitored. You are not only monitoring those parameters, if needed, if some control action is needed to be taken, so those information are already fed inside the controller. The controller instructed, and the ground devices, field devices follow those instructions. Done. Number two, there are certain signals that can be dealt in the digital fashion because of its easy nature. Normally we go for, it's not like that we cannot go for multi-level signals, but normally, for example, you take the binary signal which is used to basically opening or closing of a valve, okay, or switch on off, or these kind of binary actions. So because these are the only two states, I can easily handle by one single bit, so need not to go for a continuous signal, because ultimately it will increase my bandwidth requirement. Done. Number two, inside that particular system, let's say you constantly need to monitor the pressure. Not only that, you also have to regulate the pressure time to time. Sometimes you might need to depressurize the entire closed chamber, because it's a closed chamber, so it always have a certain pressure inside it. Even if you will keep zero pressure, with time it will automatically build up. Okay? Why? Because external atmosphere is not 0 degree Kelvin. It has a certain temperature. So if the inside environment is exposed or partially exposed or partially influenced from the external environment, it will automatically start heating up. Okay? Now variation in this temperature depending on the actual profile, but if temperature varies, we all know that temperature will automatically, if temperature varies, pressure will automatically regulate. Done. So it has, that means I need, if it is a closed chamber, I need the depressurization action. Sometimes I need to pressurize it, probably the pressure is less, I need to maintain higher pressure to do the needful task. Okay. Then at the same controlled pressure, probably I want to feed those material or gas or whatever it is to the next section. Clear? Now if I am feeding something, then probably I need some inputs also. Isn't it? Okay? So for input, that means I need to fill it. So probably I need filling action, depressurization action, feeding action, pressurization action, one after other. So that I need to not only continuously control it, but also monitor. Let's say right now my stage is feeding section. So I am feeding that particular, for example, it's a compressed gas or compressed air, compressed nitrogen, whatever you take. Okay? So you are feeding this material to the next section. Your pressure requirement is 4 bar. Now you cannot say that once I have started feeding, I will not bother about the pressure. Because you have started feeding it, then if you will not do anything, pressure will come down. That should not be done. 4 bar means it should be maintained at 4 bar. So now you require some other action to be taken. So you are taking two parallel action. Also you are monitoring temperature. Also you ensure that that point of time no filling action should be there. Okay. So if you club all these things, probably to regulate one particular parameter, you might have to constantly monitor another 7, 8 or 15 parameters at the same time, because they are get influenced with one another. Okay? One action is related with the other. Sometimes it's like a chain reaction. Done? So that means I need continuous control and monitoring, I need discrete control and monitoring, and for some cases I only need to monitor those parameters. So the third case is the most easiest, because I did not to do any control action, I just have to monitor those parameters. Remember, I am still monitoring on a continuous basis. Okay? But those are maybe ancillary parameters, not very important, but may influence my system. So that's why I am continuously monitoring. Right? So in such cases, sometimes you need continuous signal, and sometimes you need discrete signal. When I say discrete, so for me it's a discrete digital in principle are the same. Okay. Now we started from our discussion from a point that there are certain physical parameters. Now what do you think that these physical parameters, whether it is a pressure or temperature or humidity or anything else, it is by default available in a continuous mode or discrete? We are observing the temperature of this hall. So right now this temperature profile of the hall, if I will start observing it, it is a continuous signal or it's a discrete signal? Continuous variable, discrete variable? Continuous, no? Right? Is it? Now if you have any barometer kind of things where we treated mercury, so it will try to follow attain a certain pressure, so reach to the neutral point, that is x is equal to y. So because of that action, your on barometer your mercury will start getting higher position if the temperature is increasing. If temperature is decreasing, it will also decrease. Okay. So that's a continuous signal. But on the other hand, if I have a digital temperature measurement system, so I will get some digital data, maybe in numeric form, maybe in some symbolic form. Right? But what is the influence of original temperature profile? Continuous. Right? If I will start monitoring the change in atmospheric pressure inside a chamber, then that is a continuous or discrete? Continuous. Any doubt? Humidity of the environment? Continuous. I am interacting with you, so you are able to hear me through the voice signal, because both of our sensor can appreciate at 0 to 4 kilohertz frequency range. So if you say something, I can appreciate. If I say something, you can appreciate. Is this a continuous or discrete? Continuous. Anything available in nature, by default always available in continuous form as an abstract signal. It's available in abstract form and the type of signal is continuous. Remember, should not have any confusion. Okay? We do not have a mechanism. Probably my sensors has certain limitations, because of which if there is some small incremental change, I cannot appreciate. So I make some man-made media through which I will be able to measure those parameters. That's how analog measurement system comes into the existence. Clear? Then with time, we experience that whatever my analog measurement system is, it always comes with certain error. Now this error may be due to the limitation of that man-made device, or that error occurs due to the limitation of my own sensors. Getting my point? So the moment your device is correct, I had a certain limitation and my man-made device also offers certain limitation, comprises of the two gives me certain error. Okay? So to quantify that error, that means to segregate that error properly and to make sure that I can rectify that particular error, we now prefer to establish or to deal with a digital based measurement system rather than its analogous version. Correct? So when you are feeding any data, remember it is available in this form. What is it? What do you mean by CA? CA means not chartered accountant. It has nothing to do with us. Continuous. A for, let's say, amplitude. So when I say amplitude, basically this part is indicating the strength of my signal. If strength of signal is weak, amplitude is relatively lesser. If strength of signal is high, signal level will be high. Okay? So it's a continuous amplitude. DA means discrete amplitude. Okay? Done? CT means time. DT means discrete. Okay. So when I fitted this data, it was available in continuous amplitude, continuous time. Yes or no? Yes. Let us, for our understanding, we take a reference, that is a function which is varying with time, and the simplest mode of function I am taking once sinusoidal. Okay, original form of information is much more complex than this. Okay, but I know that you all are aware with the Fourier series expansion. So with the help of Fourier series, you can model any n order function. Okay, if I can design a media or system through which I can not only collect the DC value, but also all the n number of harmonics together at the same time without any distortion. So that is a condition by which I will be able to generate and regenerate any form of signal. Doesn't matter how complex, how easy it is. Okay. So the simplest form here I am taking a sinusoidal wave, where let's say here I assume that this one is 0 volt, this one is, let's say, maximum is 5 volt, this one another 50 bit minus 5 volt, and with this it is varying, that is time period t. This time period you can take any value. Right now I am taking it as a reference. So let's say this capital T is equal to 2 milliamp. For my reference, you take any value. Okay? So from here you will work out the operating frequency, at which frequency it is operating. Okay? Now this one is continuously change in amplitude, continuously change in time. So can we appreciate that any analog signal the characteristic of any analog signal can be represented in terms of continuous amplitude and continuous time signal. Correct? Any doubt? Now you heard about the sampling process. You might have studied two things, sampling and quantization. Yes, no? So what is sampling? Which one? Horizontal part, discrete. Which one will be discrete? Time part. T amplitude. Time. So the sampling is a process, okay, by which the discrete component or the discrete part of a signal, should I say discrete? I will say that independent variable of a signal can be discretized without dealing or affecting the dependent variable of the signal. Can I say this? Generic form. Y is dependent, X is independent. So I am trying to discretize the independent variable without affecting or without changing the mode or the characteristic of the dependent variable. Right? So the characteristic, so in that process is called sampling, the device is called sampling. Apply one capacitor in shunt, that will become sample and boost. So what do you get? Continuous amplitude. It is still continuous because that is dependent part. I am dealing with independent part. So independent part is not discrete. Correct? So that means this entire 2 millisecond time period I can discretize into number of components. Correct? Let's say I have converted into 4 pieces each. Okay? So half cycle is 1 millisecond, divided by 4 is 0.25 millisecond. So basically my sample time now is each piece, this one is consist of 0.25 milliseconds. Yes, sir? Okay? So I am assuming that because people have already studied the Nyquist criteria, so you have said that this one shall be maintained. This is what you studied, huh? And you also studied that as far as the industry application is concerned, this simple analogy is not going to work for you. So that you need to vary depending upon the type of signal. If it is a flow, relatively easier to deal with. If it is a temperature, much more complex. depending on your sampling period will vary. Doesn't matter, it's 5 times, 10 times, 20 times, whatever is, but you can fix some value. Okay, if Fs is greater than YSFM not working, you go for Fs is working than YSFM, 5FM, 10FM, whatever is, but fix some value. So I am not bothering about it because you know the maximum modulating component. So if the maximum frequency is known, that many times I can go, I can satisfy this property so that my two sample values should not interlace with each other. Their boundaries should not coincide. If there is a coincide, that means there is a superimpose. Superimpose means loss of information because you cannot regenerate. Okay, that is the problem. So have some gap, have some little bit gap between two samples. Mind. Okay. So that is what we have done using sampling rules. What quantizer is doing? Reverse. Is a process which is used to discretize the dependent variable of the input signal without affecting the independent one. Is it touching independent one? So that means whatever input to the quantizer, its job is to discretize this one. ठीक है ना? This one. ठीक है? So here I got discrete amplitude because of this characteristic, because of the job of the quantizer. Input was continuous amplitude, discrete time. Now it will become discrete amplitude, discrete time. Idea is clear? Any confusion? If I will record the process, what will happen? Think of it. Take it this one as an assignment question. There is a signal which has the characteristic of continuous amplitude, continuous time. We are going to feed it initially through the quantizer. Then we are going to feed the outcome of the quantizer to the sampler. And here I am expecting my output or response. That is the question. Okay? Take this as an assignment question. Solve it in a detail. Okay? Now you think what will happen? Input to a quantizer is continuous amplitude, continuous time. Okay? What will be the output of the quantizer? अति मानस तो बची गला कौस्तव भाई बताओ इसको पहले अटेंडेंस पे रास्ते में गेट अ क्वेश्चन क्वेश्चन बुझिएगा हैं हाँ कि ना आंसर if I will feed a signal which has a characteristic of continuous change in amplitude and continuous change in time through a quantizer, what kind of characteristic I will experience as the output of that quantizer? Signal will remain same, na? Or is it something like I will feed a voice signal, I will get video signal? ये तो लेकिन बढ़िया है, नहीं? हैं? नहीं? हैं? हॉस्टल में पढ़ रहे रोटी ये नहीं खाता है, पढ़ रहे पास्ता नहीं? Unfortunately not possible. नहीं? 80%. आइए. कॉपी पेन धर गया वीडियो रिकॉर्डिंग हो रहा है ना बीच बीच में जो बढ़िया स्टेटमेंट चली छत्तीसगढ़ वाला भाग्य काउंट 80 ये तो 80% है चला आज दिनड़ा हनुमान की दिन हाँ भूल से नेक्स्ट बताओ भाई स्वाधीन I repeat again, sampler is a device which is used to discretize the independent variable of a input signal. ठीक है ना? Okay. Quantizer is a device which is used to discretize the dependent variable of the signal. Out of amplitude and time, which one is dependent, which one is independent? Tell me. That's it. Right? Time is dependent or amplitude is dependent? Time is dependent. कहाँ हो रहा है भाई? एस्ट्रोनॉमी में वैसे सीरियल देखने हो तो हैं? I also agree. समझे जितना चक्रधर मुँह भीतर আছে, हमारे कैपेसिटी नहीं ना बाहर बस बाहर देखिए अपन मुझे लगा था तो अर्जुन को देखे नहीं थे हमने इतने बड़े पुण्यात्मा को नुआ से फिर आसिक देखे जो हमको और देखे दे गए रेफरेंस बुकटा लिख दे गए श्रीमद् भगवद गीता पढ़ियो बुझे लगा हैं ना पूछे कि जल्दी जैसे बोला भाई हॉस्टल बाहर तो ऐसे चल रही है तो दोस्तों हाँ टाइम इज डिपेंडेंट बढ़िया इस स्पीड में यदि वो 40 मिनट है एक व्हाट विल हैपन quantizer will discretize the amplitude vertical part is dependent on horizontal na so what I will get
discrete amplitude
now this one I am feeding to sampler so what I will get here
discrete amplitude discrete time
it will not affect amplitude part so it will remain same it is actually not bothering the body ठीक है जी it is simple so theoretically if I want to generate a discrete signal using the combination of sampling and quantizer do you think that the position of the sampler and quantizer does matter okay keep this thing you will remember now we are going to feed a encoder here you see encoder na so now encoder and decoder both works in a complementary fashion है ना if I have a binary encoder in the transmission side I will have a binary decoder in receiver side है ना octal decoder रख ले तो चलेगा नहीं here you feed a ASCII signal and there you feed a have a octal decoder will it work because ASCII is a combination of numeric plus alphabetic plus special character नहीं ना so you have an equivalent decoder correct है ना and why because both actually exchange the same protocol of communication so if you have done somewhere 1 by x so decoder is already know that where you have done 1 by x that's why it is able to decode and that is the reason that why this always works on pair like your serial to parallel converter and parallel to serial converter is a pair your mux and demux circuit comes in pair similarly encoder decoder works in tandem ठीक है they both complement each other done now so what you are doing with the encoder you are going to probably embed one additional bit okay to increase the safety or security feature of the content so that no one outsider else should able to steal your information without any permission right now level of encryption decryption forget about it that is the basic characteristic of the encoder right even you will design the simplest encoder its job is the same if you are going to join up develop a complex encoder depending on some cryptology then it will be obviously difficult to decode not impossible but difficult to decode done so what do you think that encoder is changing the characteristic of input signal no you might have studied the parity bit first level of encoding what you do you add one extra bit play with 1 or 2 bits to change the reciprocal of the frame and where you have done a change that is already known to receiver if you know it you can regenerate okay otherwise it will show an error because you have transmitted something, but receiver will receive something else. Correct? So in those scenarios, you see, this device is there just to add some security features, but it is not going to play with the characteristic of the signal. So output of the encoder is also discrete amplitude, discrete time. Whenever you have a A to B system, it always comes with some specific encoding feature, and this white box is the collection of this. Okay, theoretically you can think of that, okay, I will add encoder separately, you can, but nowadays not. Okay, those philosophy 1-2 decades back. Okay, now it always comes with that feature. So, therefore, now this output is called a digital signal. This output is called a digital signal. This output is called discrete signal. Okay, this input is called continuous signal. Understand? So, in principle, there is no difference between discrete and digital, except the coding. It is either coded or uncoded. Done? So, we don't bother about it. We are right now more focusing on the characteristic of signal. It is not changing the characteristic of signal. So, if it has some encoder, put some decoder at the receiver end. If you do not have an encoder, don't bother. Getting my point? Now, if time is an independent variable that you have discretized, do you think that to recover that time, okay? Earlier it has a continuous cycle, the entire cycle was 2 milliseconds. You discretized 2 milliseconds into 8 samples, okay? So ideally right now I am not considering any gap between two samples. So it's a 8 sample pieces, that means it is sum of 8 pieces to generate entire 2 millisecond time period. Correct? Now this reference was independent. So if some reference is independent, do you think that at the receiver end I did something else to regenerate? Did you get the question? The sampler job was to discretize the time component, or in general I would say independent variable. Time is an independent variable. Frequency is also independent variable. You are dealing one of the frame, right? So whether it's a frequency or time immaterial, do you think that you required any other reference to define a independent variable? Reason. Let's say my IST reference has come somewhere, Indian Standard Time. Okay, it is passing through nearby the Jabal, one of the major cities. Okay, considered as nearly the center of the country, near the center, not actually. But because in that periphery it is one of the very old setup is there, or some reference point is there. So that IST time. So if I will observe the same watch here in Odisha, will it show some different time? Gujarat, Kashmir, Kanyakumari, Paradip, Sambalpur. No. So it's independent variable. You have taken some reference, so it will be the remain same until unless you are not going to change your reference. Go for Chinese time, now it will change. Done? Because their 24 cycle is referred from that framework. Okay? So unless you are not going to change the frame, it will remain same. So you had discretized that time component, which is itself independent. Do you require any other reference to redefine it? No. You simply need to integrate it. Understand? Now, what was the amplitude? That was dependent, na? Now let's say what is the simplest form of digital? Binary coding, na? Okay? Why you have done that? Because you record single. Now my entire, what was the voltage level? 0 to 5. Right? Okay? So I am not concentrating about the polarity. So it's a 0 to 5. 0 to 5, my mid band is 2.5. Done? I would say that if anything below 2.5 volt, refer it as 0. Anything equal or above 2.5 volt, refer it as 1. Chalega? I am referring positive logic, you can go negative logic, reverse. No problem. Done? Okay? So now, with respect to each sample, where I got my first sample? Here. So here I check what was the amplitude? Above 2.5. So can I recognize this one as 1? Can I take it? 1. First I am taking 0, then 1. What about next? What about next? What about here? 0. So if I will take it, this reference, first chain, second, third, fourth. You have generated 4 samples only, na? So first time it switched from 0 to 1, then 1 to 1, 1 to 1, then there is a here as well. Okay? Now, if you will not provide that what was your coding level, okay? Now the receiver end, what is the input? Discrete amplitude, discrete time, because you have discretized both the components. Done na? Now receiver end, how will we generate? Any approach? Why regeneration is needed? Because that pressure was continuously varying na? Inside the tank. है ना? So you pick that signal, then you apply some data communication media. Let's say that data communication media is itself digital. Even if it is analog, you transmit it in analog form, but your digital controller is digital. It will not understand that continuous change in pressure. So you will give a reference that okay, my reference is bar or my kg per centimeter square or meter square, whatever your unit is. Okay, SI unit, whatever MKS unit, whatever you follow. But then you will say that okay, right now I got 1. Now what your controller will understand? What is 1? 1 means if the total pressure is 4 bar, so now what means 1 means what? Is it 2 bar, 1 bar, 0, 4, what? Because on every 0.25 milliseconds you are getting 1 sample. Okay? So in each cycle you are getting 8 samples. If the job is continuously going, multiply by n times. Okay? So first time you will get this. Now what you will get? 1 or 2.7? 1. Okay? Next sample, you receive 1 or 5 units. Next sample, 1. How many more? No idea. No idea. But you know one thing, that I adopted binary pattern. Okay? Right? So if it is binary, that means definitely more than 2.5. No question about it. Okay? Now what about 2.5 to 5? Can be anything. Right? Do one thing. Do a little bit of trouble, rather than binary, you take 2-digit pattern. Okay? So my 2-digit byte will give me one extra option. Okay? Here, rather than one single label, I can define 2 more labels. Then in octal you can double it, hexadecimal further double it. So if I will do 2 raised to 1 in place of 2 raised to 2, 2-bit pattern, I will have 4 options here. Now each discrete output dependent variable will give me a reference of 1.25. Correct? Anna? Okay. So this one is now 3.75. 3.75. Now can I classify in a better way? Yes? If it is octal, then much better. Why it is happening? Because you are converting it to small pieces. If the gap between two quantization level is less, the error is 1 by q. Earlier error could be 2.5, isn't it? 1 upon 2.5, right? Because it is considering 2.7 volt also as a 1, It is considering 5 as also 1. But if I will take 2-bit pattern, now my 2.75 has a different coding than that of 5 bit. Yes, so I am in better position to negate that error. Why? Because I have an extra edge. If I will go for 2 raised to 3, 8-bit pattern, error will be reduced by 1 by 8 times. Hexadecimal 1 by 16 times. Each decoded frame will offer you maximum 1 by 16 times of the error. If error you can reduce, signal prediction will be high. If your signal prediction is better, you can regenerate that data. Otherwise, remember, there is no way by which you will be able to recover your digitized signal. You can recover time, but you cannot recover discrete amplitude at all. Clear? Getting my point? So, because time is an independent variable, so therefore I did not bother in D2A conversion. Here I fitted my decoder. Do you think that any conversion is there for time? Nothing. I am simply integrating it. And for integration I don't require any media. I just need to define the upper limit and lower limit. That's all. यहाँ से start करना है, यहाँ से खत्म करना है. That's all. Okay? So what this 0 volt circuit is doing? It is collecting each sample, holding for definite period. That depends on the value of capacitance. You can work out the value of RC because that circuit has some resistance. So for RC you can know time constant. So with that of that time constant, you know that how long this capacitor will hold the signal. You want to release it, it will unhold it. It will release. That's why you call it sample and hold. Hold for a moment. That holds reciprocal. Here is called zero order hold circuit. The best one. Everything may not be zero order, but in nowadays we always use this zero order. Remember, right? So what is this zero order? It's nothing but it is a simple low pass filter. That's all. Okay? It's a simple low pass filter. Again, your low pass filter lower frequency band is not exactly 0 Hz because you cannot define it. Take it some numeric value. If my operating frequency is 50 Hz, I can take the reference 0.5 Hz. 10 times lesser, I can easily quantify the difference between 50 Hz and 5 Hz. Let's say this whole plane is frequency. Now there is a frequency whose strength is 0.5. There is another frequency whose strength is 50 Hz, nearly 100 times higher. Right? Can I easily distinguish it or not? I can. I know well in advance that this 0.5 Hz is nothing, but it is as good as a 0. Just leave it. Wherever is 50 Hz is appearing, collect those samples. Right? So, in that way, you can keep it here. You see that here you fitted discrete amplitude, discrete time signal, but here you are going to generate continuous amplitude, continuous time signal. That's it. What exactly you need. Get it? So you will revert back this continuous signal. Once you got this continuous signal, you are displaying this continuous signal on display with the help of that bar graph or color code. So that's how your human intervention is came to know that okay, how it is changing. Right now increasing, decreasing, it's constant or not. So it follows exactly same principle what you have done under the head of your mobile or long distance communication. Working principle is exactly same irrespective of distance. Distance is one problem which we have do not experience in industry application because my industry is limited well within the range of 5, 10, 50 kilometers. Not a long distance like 100, 200, 1000, 2000 kilometers. Okay? So your communication guys require some different expertise, but we don't require. Getting my point? So how many samples it has collected? Finite samples? Finite samples? So can I redefine it in terms of finite input and finite output? What is this? Error signal, remember, right? And what is error? The difference between the transmitted and the received signal now. Okay? Transmitted one was the set point reference, received one is the actual feedback. So, ideally there should not be any error. But can I assure? No. So, I am considering there is some error. And let me try to rectify or identify an area through which I can compensate this error or neutralize this error. If I can neutralize this error, it is as good as a guarantee that I can regenerate my original signal. Okay? So better than noise rejection scheme is you will get better signal. ठीक है? So you can regenerate this. Rest I am not dealing here. You have a two approach, instantaneous and one is natural sampling. Instantaneous sampling you already might have studied. Theoretically very good, practically difficult to regenerate when you are going to design a 0 volt circuit. So this is one of the reason. You can go for a combination of low pass filter. You can go for a combination of equalizer. What is equalizer? What is equalizer? Duty cycle you have कितना आएगा? T by Ts. Ts is a sample time period known to you. T is already known to you. So doesn't matter whatever your duty cycle is. T by Ts is known. Can I treat it as a constant? Skip it. Remember, if constant is doing some problem with your transmitted signal, receiver end में क्या करोगे? Multiply it by 1 by k. If k is my input constant, at output you simply convolute it with 1 by k signal, so it will reject it. कैसे समझ आएगा ना? कोई problem नहीं. What is the rest? This. That is the problem, na? Right? So let's say assume it is a like of a sample of. It is like this signal. You know that this one is your information. This one is additional phase shift. Decrement signal जा रहा है ना? Like this. Right? This is your plus minus 3 dB band. You know that here I am going to collect this information. What I will do about this? I am not considering it. Rest of the part beyond bandwidth, but it is there. What should I do? At receiver end, multiply that signal, because if you know that factor, e raised to minus j omega, omega is known, Ts is known, y2 is a constant. Okay, so if I am treating x is equal to omega Ts by 2, can I simply convolute it to the receiver end with the help of 1 upon e raised to minus x? कर सकता हूँ ना? If e raised to minus x is known to me, can I multiply it with 1 upon e raised to minus x? Simple. Can I do it? If you will do that, what will happen? That is the phase shift error. That will cancel out. That will cancel out. So what else remain? This part is cancelled. This part is cancelled. What is remain? This one. Recover. Understand? Now, is it a full information? Answer is no. Because you compromise with plus minus 3 dB band. Remember, plus minus 3 dB band is mean, not the complete signal. Right? You have a mode, median, mean. Study करते हो ना? Where you are getting mean? At plus minus 3 dB band. Beyond 3 dB band, because it had offered me less than 50% power, so I chose to leave it there. Because I leave it there, now I cannot regenerate. मैंने transmit ही नहीं किया तो regenerate कहाँ से करूँगा? Possible है? Whatever I transmitted, I can regenerate. Whatever portion I deleted in the transmission, and how can I regenerate? Now it will give me some error. That error is there. Okay? So now if you know that error, you can suppress it. Number one. Number two, even you have suppressed it, whatever rest was there, is it a full information? Answer is no. So what you will do now? Now apply that philosophy. Okay? Have a standard system so that you will be able to ensure the transmission of more than 90% of the data in the worst case scenario. I used to give this example 100 times. Your paragraph consists of how many? 100 words. Okay? You have texted me something, but I received 91 words. 9 left. So this is something like a fill in the blanks to me. But if my content, rest of the 91 words that I received, is it in sequence or not? If it is in sequence, am I in position to fill up remaining 9 gaps or not? I can try. Okay? You can make my job much easier if you can ensure that my transmission rate should be more than 95%. If it is something like 95.4 or 6, is as good as that I lost 4 words. I can easily regenerate, right? So you have a different methodology for that. Don't try here. to transmit 100%, receive 100%, because otherwise that will comes with the cost of huge bandwidth. That is something which is not free and you cannot offer. Ready? So in this way you will go for instantaneous or you will go for natural. Natural sampling you also studied, I know. Okay? Natural is easy to generate. Why? Because natural में तुमने क्या किया है? There is even use one more term. You call it flat top. Isn't it? There is a natural sampling and there is a flat top sampling. Flat top में क्या करते हो? You just simply clamp or click rest of the thing. So something is constant, easy to regenerate. But it will comes with error or not? Yes. Can I have a regeneration approach? Yes. Okay. Okay. So use those techniques to go for it. All one.
So down to
How much time left? No, 10. Last 9? 9. Not a little money. आज मूड अच्छे डिस्कस करते हैं. So next topic is your standards of instrumentation. ठीक है? In one of the class, probably I have told you to study about the current, voltage standards, power standards and all. Studied it? Right? Today we will discuss. So that is primarily called standards of instrumentation. अब तुम बोलोगे भाई इंस्ट्रूमेंटेशन इतने बड़ा है कि तब स्टैंडर्ड्स पे तो कब पढ़ रहे हैं. Standards of instrumentation. How many basic signals you require to define?